Good morning, third grade. Welcome back. Today we're working on Module 7, Lesson 4. Oh, yeah. Okay, let us start. Actually, I have already gone ahead and cut out all of my shapes from the template. If you haven't done that yet, will you please go do that? If you printed out the template, please go ahead and cut those out. Give this a pause. Go cut those out and come back to me, okay? If you don't have the template, if you're not able to print it out, no worries. You can just follow along with me, okay? Okay, so I've already done that. So now that we have lesson 4, whoa, will you read the bottom with me? Please compare and classify quadrilaterals. Let's read number 1 first. Cut out all the polygons A through L in the template. Check. Then use the polygons to complete the following chart. Okay, so far we've heard 2 words that we might not know what they mean. Quadrilateral and polygon. Poly means more than one, and gon is a shape. So it means a polygon is a shape with more than one side, has multiple sides. A quadrilateral is a shape with 4 sides, right? Because quad means 4. In Latin, maybe? Okay, so what we need to do is fill out this chart, okay? So it says write the letters of the polygons in this group. So we have Y and Z, and this is the polygon. So we're going to find all of the polygons that have 4 sides, which is maybe all of them. I don't know. Okay, all we need to do is list them. We're going to sketch 1 polygon from the group. We do not need to do all of them. Okay, so let's see which have 4 sides. C does. C has 4 sides. H, 1, 2, 3, 4. H has 4 sides. I, yes. 1, 2, 3, 4. L, I like that one. A, kind of looks like a spaceship or something. 1, 2, 3, 4. K, B, E, J. Basically, they all have 4 sides. G, and F, and, D. Okay, so now you can sketch any one that you want. So just choose one and do your best drawing of it. I want to do this one because I like this one. Sketcheroo, we'll go a little triangle on the bottom. It's a little flatter. Okay, I like it. Which was your favorite shape? Okay, the next one says at least one set of parallel sides. What does parallel mean? I will tell you. Parallel, let me get my, what's this thing called? Whiteboard. Let me erase my business here. So parallel lines are going to be like a railroad track, for example, okay? So these 2 lines are parallel to each other. So this would be one set of parallel lines. If I do this, these 2 lines are parallel, right? They're just going the opposite direction. They're still parallel. So lines that will never cross, lines that if I make this go on forever, I make this line go on forever, they will never cross, okay? Now if I have a shape that has one set of parallel lines like this, maybe a line like this, and then a line like this, how many sets of parallel lines does this shape have? It just has one, right? This line and this line are parallel to each other. 1 and 2. These 2 lines are one set of parallel lines. How about these ones? Are these ones parallel? Mm-mm. Because if I were to draw, let me move this up a little bit. If I were to draw this line and this line down, they would eventually cross. If I were to continue this line and to continue this line, they would eventually, I can't really see it. They would eventually touch, which means they cannot be parallel. Parallel lines will never touch. Okay, there's another kind of parallel line. There's another set of lines called perpendicular. Say perpendicular, it's fun. Beautiful. Perpendicular lines are like this. And they create a right angle right here. We'll get into right angles if you're thinking, Mrs. Brady, you lost me. No worries. But if you're with me, great. So these two lines are perpendicular to each other. These two lines are parallel to each other. Okay? So that's what we're looking for. We're looking for parallel lines in these polygons. So let's just maybe we'll just go in alphabetical order. Where's A? Oh, I left her over here. Okay, A. Any parallel lines? No. If these two lines are already touching, this can't be parallel to this. This and this line are definitely not parallel. If I continue these two lines, they will touch. So no, this has no parallel lines. Adios. How about B? How many parallel lines does it have? If I can extend this top line and this bottom line forever, will they ever touch? No. It has at least one set of parallel lines. So let's classify that. Let's pop that in our group. B. How about C? Where are you, fella? Here we go. How many sets of parallel lines do we have here? These are parallel, right? If we continue these on forever, will they ever touch? No, ma'am. How about these? No, ma'am. This one actually has two sets, right? Well, so did B, but moving on. A, B, C, D. Where are you at? Here's D. What do you think? Do you think this has any parallel lines? Can you find any parallel lines in this one? Is this line parallel to this line? No, because they're touching. Is this line parallel? No. No parallels. By D. Sorry. A, B, C, D. E. Here we are. Any parallel lines for this guy? If we were to extend this line and this line forever, boop, they would touch. It wouldn't take long. How about these two? Exactly. These two are parallel. So we're going to add that to our lot there. A, B, C, D, E. Look at that little square. How about this one? Does that have any parallel lines? It does. This line, these two are parallel to each other, and these two are parallel to each other. F, B, C, D, E, F, G. How about this one? This one's a little bit more curious because it looks like it's a little slanted. But it does look like these two lines are parallel. And believe it or don't, these two lines are parallel. Even though they're a little bit slanted, they're still parallel. Because if those two go on forever, will they ever touch? They will not. I'll tell ya. Let's add G to our list there. How about H? Parallel? Yes. Two sets, huh? We're only looking for one. A, B, C, D, E, F, G, H, I. Okay. What do we think about this guy? Looks kind of like a square. What do you think? I think that these two lines are parallel and these two lines are parallel. So I would say yes. Yes. I. How about J? This line, this bottom line and this top line are not parallel because this top line is a little bit slanted. And were we to go on forever, they would eventually touch. However, these two lines look parallel to me. Do you agree with me? Thank you. Call it J. H-I-J-K. How about this one? Are any of these parallel? These ones are clearly not, right? This side and this side, if you go on, boop, they will touch. How about these ones? I think I think that these ones would touch too. They're a little bit slanty also. So no K, you do not fit our qualifications. And how about L? Yes, you are right. This has actually two sets, one here and one here. So, L. Now it is our task to sketch one polygon. You choose any one you like, so long as it's from this group. Yes, you're not going to start sketching K because it doesn't fit our qualifications. I'm going to do B. You can choose any one you like from the list that we've just created. There we go. All right. Now we get to do two sets of parallel sides. Okay. Do you think that this group will have more than this or less? Agreed. I think it will have less, but let's see. So let's just get these ones out, because if it has one, then it might have two, but it doesn't have any. It's not going to also have two, right? So let's get B, C, E, F, G, H, I, J, and L. Okay, so A, K, and D are to the side. Those don't even have one, so they're certainly not going to have two. Okay, should we start alphabetically again? Why not? Let's just do that. So first comes B. How many sets of parallel sides? Does this one have two? Yes. 1 and 2. Yes? 1, 2. 2 sets. You have met our qualifications, sir. Congratulations, you're in the running. Okay. Is C part of our group here? Yes. Let's look at C. How many sets of parallel lines? We have at least one. Are there two? Yes. 1, 2. Yes. Good job, C. You've met our qualifications. C, D, no, E. Okay. What about E? Does E meet our qualifications? No. Has one. But these two sides, if go on forever, they'll touch. Sorry, E. You've not met our qualifications. How about little tiny F? F is kind of a small version of C, right? So if C has, or B, if C has 2 sets, then F must have 2 sets. Most certainly. You've met our qualifications. Congratulations. Join the ranks. How about G? What do we think? This side is parallel. Is this side parallel? Even though it's slanted, could it be parallel? Yes. Why not? It most certainly is. There's G. You've met our qualifications. Congratulations. H. How about this long fella? Does this one meet our qualifications? Absolutely. Has one set of parallel lines here and one set of parallel lines here. Thank you, H. Join the ranks. How about I? Kind of helps for me, like looking at it in different angles. Like if I look at it like this, it doesn't really look parallel, but if I turn it, I can see that these lines are parallel and those lines are parallel. So yes, I, join us. How about J? How many sets of parallel lines? Whoops, I just knocked my whiteboard off the desk. Oh well. It has one, we can see. It met our qualifications up here. However, this line, these 2 lines would meet. Would they go on forever? So no. Sorry, J. Do not meet it. Our qualifications. How about this one? What do you think about L? Do you think it has 2 sets? I do too, right? It has this one and this one. L. Now please choose any one you'd like to give a little sketch to. That is, of course, in this group. I'm going to sketch G. Make sure my lines are parallel as I'm sketching, or close to parallel, right? If you want to use a straight edge for this, you may. Okay. Okay. Now we're talking about 4 right angles. I know I talked about this a little bit when we were talking about polygons. So let's revisit that for a moment. Where's my thing? So a right angle is an angle that is a perfect square, just like my straight edge right here. So if you can fit the corner of a piece of paper into a corner, then it is right angle. So this polygon right here, quadrilateral in other words, because it has 4 sides, has 4 right angles. How about this one? This little creature down here that I've created. Does this have 4 right angles? Well, let's see. Has 1. This is a right angle. And this is what they usually will draw to show that it's a right angle. This is a right angle. No. Can I put that in there? No. You have to be able to see both lines on the outside in order for it to be a right angle. Can you see both sides? You cannot. So that is not a right angle. So this polygon or quadrilateral has 4 sides, minus this business, has 2 right angles. So what we're classifying next is a polygon with 4 right angles. And what I want you to notice is the relationship between parallel lines and right angles. If I have a parallel lines here and parallel lines here, do I have 2 right angles? I do. I mean 4 right angles, excuse me. However, this is where perpendicular comes in. When you have a perpendicular line, this is when you get a right angle. Looks like a little chair, right? So if I have 2 sets of parallel lines like this, do I have any right angles? Is this parallel? I mean, is this perpendicular? It is not, right? So a perpendicular line would go straight down. This is perpendicular, making this a right angle. This is not. This is not a right angle. Okay, I hope that was kind of clear. Let's move on to classifying, or identifying rather, shapes with 4 right angles. We can already count out all of these. These ones that didn't classify with 1 set of parallel lines, they're also, none of them will have 4 right angles. It's not gonna happen. So I'm just gonna tell you that right now, and we're getting rid of them. So let's go down our list and see which of these has 4 right angles. Let's start with B. I'm gonna take my little fella here, my little corner guy. You can use any piece of paper. Like Seamus has this like Post-it. I could use a corner of this, right? That would work. So any piece of paper you just have lying around will do. So let's see. It fits perfectly, there's 1. It fits perfectly, there's 2. Fits perfectly, there's 3. Fits perfectly, there is 4. This has 4 right angles. Good job, B. Fabulous. How about C? Let's get C out. What do you think about this? Let's try 1, 2, 3, and 4. We have 4 right angles in C. Yes. How about F? It might be small, but does it have 4 right angles? Yes, you might be noticing a pattern here. Rectangles and squares have 4 right angles, don't they? Every corner is a right angle. How about G? My computer went to sleep here. Wake up. Okay. How about G? If I put this in here, that does not fit perfectly, does it? Nope. And if it doesn't have one right angle, it's certainly not going to have four right angles. Every polygon, each quadrilateral, I should say, if it has four sides, it's going to have four angles. So this is an angle, this is an angle, this is an angle, and this is an angle. Four sides, four angles. If one of them isn't a right angle, then it's already out, right? It's already out of our classification. Okay, how about, what was that, G? How about H? Can you tell by looking now that we've done this a few times? You're right. This is going to have four right angles. And we can prove it too. There's one. There's 2, 3, and 4. It fits perfectly right inside of that little nook, right? Those are four right angles. What's next? Nothing with E. I. What do we think here? Not quite. It looks close, but it is not, right? It does not fit perfectly. We have all this extra space. So I, no good. How about L? Certainly not, right? No. Okay, go ahead and sketch any one of those that met our qualifications. I'm going to do H. Excellent. Okay, now we're on to the last one. We need four right angles and four equal sides. So out of all of these, which ones can we rule out? Which ones definitely don't have equal side lengths? Yeah, H, right? These sides are super tiny. These sides are long. No, that's definitely not going to have equal sides. What else can we rule out? B, right? Again, these sides are shorter than these sides for sure. Goodbye. How about C? I don't know. It looks kind of close. You know what I'm going to do is on my little straight edge, I'm going to kind of trace one side and then measure the other side against it. So here's one side. And then if I turn it, oh, look, this side is longer, right? Because this side is perfect. Matches exactly what I drew. When I turn it though, this side's a little bit longer. So C, nope, you do not have equal sides. I bet F does. Let's see. Let's use our little measuring technique here. I'm just going to trace one side and then compare it with the other side. Well, wouldn't you know it, it matches perfectly. That's the only one. The only one that has four right angles and four equal sides is F. So now, do your best to sketch a square that has exactly equal sides. Easier said than done, huh? Okay, looks pretty good. Let's flipperoo. Oops, sorry. Will you read with me, please? It says, write the letters of the polygons that are quadrilaterals. Explain how you know that these polygons are quadrilaterals. Like I said before, every single one is a quadrilateral because every single one has four sides. Now, this one, this Y and Z, this mysterious ones that we've never seen, those are not quadrilaterals, right? Those are called triangles because they have three sides. If it has four sides, it's a quadrilateral. So that is going to take care of the explain how you know, right? So we're just going to write A to L, okay? So write the letters A, B, C, D, E, F, G, H, I, J, K, and L are all quadrilaterals. I know this because why? Go ahead and fill in my sentence, the rest of my sentence. How do you know that they're all quadrilaterals? I know this because each of them have 4 sides. And that's all it takes to be quadrilateral. You don't have to have parallel sides, you don't have to have perpendicular sides, you don't have to have anything except 4 sides. It's the only qualification in order to be quadrilateral. Okay, let's head down to number 3. Will you please read with me? It says, sketch a polygon below from the group that has 2 sets of parallel sides. Trace one pair of parallel sides red. Trace the other pair of parallel sides blue. What makes parallel sides different from sides that are not parallel? Okay, so if you're doing this with a pencil, go ahead and sketch any shape that has 2 parallel sides. I'm going to get my red and blue markers out. If you have red and blue, great. If you don't, maybe 2 different colors, right? Would be fine. Maybe I'll just do this in like this little pen. I'm going to sketch B. Oops. Okay. So one set of my parallel lines, isn't this weird? I don't know why this pen, all of these pens, like whenever you open them, they're all the same color, right? And this one, whoa, it's like a little surprise. Okay, I'm going to trace this side blue and this side blue. That's my first set of parallel sides. Hopefully you can kind of see that that's blue. And then my other set, I'm going to trace with red. Now I know that those are parallel. The question is asking us, what makes parallel sides different from sides that are not parallel? So what makes the red different from one red and one blue? As we've talked about before, and by we, I mean me, we've talked about before is that parallel lines will never touch each other. Sides that are not parallel will at some point touch. So let's write that for explanation. So I'm going to write parallel sides are unique because they will never touch. Ooh, they will never to be touched. Sides that aren't parallel will eventually touch. Boop. Hopefully that makes sense. If this does not make sense, if you're struggling, send me an email. I'm happy to help. I'm happy to explain it in a different way and get you to where you need to be, okay? Or if your parents are around and they're willing to help, you can ask them too. They're a good resource and they might explain it in a different way that makes more sense to you than what I'm explaining. Okay, let's read number 4 together. Draw a diagonal line from one corner to the opposite corner of each polygon you drew in the chart using a straight edge. What new polygons did you make by drawing the diagonal lines? Okay, so it's asking us to flip back over and draw a straight line or diagonal line. There's no straight edge. From one corner to another corner, right? And let's see what new polygons we've made. Okay, so no matter what shape you drew, you can do this. So from one corner to the next corner, just draw a line. This one, I can't really do a diagonal line. On this one I can, right? Diagonal is like this, sidewards. Really, on this one, I couldn't go from any other corner to any other corner. I could do this side, but there's no other option except to do diagonal. Okay, so I'm going to go this way. I'm going to go this way. That way, and this way. What have we made? What new polygon have we made? Right? So instead of one quadrilateral, we've made two triangles, right? Two triangles, two triangles. Would you look at that? And that's exactly what it's asking us. So now we have the answer to that question now that we've done that. What new polygons did you make by drawing the diagonal lines? So I'm going to say by drawing the diagonal lines, I have made triangles. Excellent. All right, third grade, that was a long lesson. Thanks for hanging in there with me. Like I said, if you have any questions, if you're confused, you can do one of two things. Step back, come back to it tomorrow and see if you understand. Ask a parent, send me an email. So one of three things, actually. But great job. I miss you all. I hope that you are having a great day, and I will catch you on the flip.